Okay, so last lesson we started looking at recurrence relations or scenarios where we had a combination of the geometric sequence and arithmetic. So what we saw was, say we had an investment where that common ratio number, that R, was a number greater than 1. And so we saw growth here, so in your investment, and then we also saw the arithmetic part of the sequence where we were adding additional payments. So today we're going to do, we're going to talk about another scenario, and that is a reducing balance loan. So this is generally what happens in a loan situation. So we have a loan, so we borrow money from the bank, and we're then going to have make payments to pay off that loan. So because we borrow money from the bank, this R value, the bank want to make money off us, off the lending. So this number will be greater than 1 because it's going to add interest on it. So it'll be the interest getting added to it, and that's compound interest. Being added. So, and that's compound interest. And then what we're going to do is we're going to then make payments. So this D is the loan repayments. Okay, so that's us trying to reduce the amount we owe the bank. So you can see the D's are negative, so we're going to minus it. So we still find that common ratio. So we've got the formula there, and it's obviously still the same way, where we have that R will be the percentage rate per annum, and PPY is how many times it's compounded per year. So if it's monthly, PPY is 12 and all that. So when we have a reducing balance loan, we just put a graph. It will be curved because it has that compounding interest like. Okay, so here's an example of what we'll see. So it says that Flora borrows 8,000, so there's my VO, at an interest rate of 13% per annum. So there's my R. Now compounding annually, that's good. So I know it's compound interest, and I know PPY is 1. She makes yearly repayments of 2,100. So this is our D value in our scenario. So it says construct a recurrence relation to model this loan in the form of, so they've put you the basic formula there for you, which we have in our notes as well. So we know that this value we need to calculate ourselves. So we're going to do that R first. So if we write the rule for R, so when we have a reducing balance loan, it's compound interest. So it'll be R plus the rate over PPY over 100. So in this scenario, it's 1 plus 13 over 1 over 100. So our R value is 1.13. So now we have that, we can write the recurrence relation. So VO was the beginning amount that they borrowed, which was 8,000. And then how we get the next value in our sequence is we're going to use the R value we found, we're going to write VN, and now we have to put the D value, which we've seen up in the things, they're going to tell us that, and this person, Flora, is making 2,100 repayments, so it'll be minus there. Okay, so let's have a look at this one. Alyssa borrows $1,000, so there's my VO, at an interest rate of 15% per annum, so there's my R, and then compounding monthly. So I know that PPY equals 12. She also makes monthly repayments of 250. So I've been told the D value there. And then once again, it's asking us to construct a recurrence relation for n months. So means they want the monthly formula. So we know that that will be taken into account when we work out that R. So if you look at the R, let's calculate that. It'd be 1, plus the rate over PPY over 100. So in this instant, it'll be 1 plus 15 over 12 over 100. And we end up that R value is 1.0125. Okay, so now we can write the recurrence relation where we have to write VO, which is 1,000. Then we write the recurrence rule, which is, I've got to put that R value in, which I just calculated, Vn, because it would be times Vn, and then we just have to put the monthly payments. And they did tell us that up there, which is D, so minus 250. Okay, so with this one, Alyssa can model the recurrence relation. So here we have a look. Now, so if just to have a look at the formula so we can see what things are there. So obviously here, when she has the $1,000, that's obviously what she invested. So in this case, so invested was, or borrowed, sorry. Well, so this is a loan, so we might say borrowed. So she borrowed 1,000, so we could read that off the recurrence relation. And we can also see here, we know her repayments that she's making, they are 257.85. So her repayments for the loans are that. So it says use your calculator to find the balance of the loan after 4 payments. So I've shown you how we can do it recursively in our calculator. So remember, you type in 1,000 and press enter, enter. And then I've done 1,000 times, then when you press it, it should come up answer here. Answer and times 1.025 and then minus that. So here's the first one. So we have after the first payment. So this would be after first payment. She owes that much. And then you just keep pressing enter. So we're doing it recursively on our calculator. And you can see it's timesing the new balance by that R value and subtracting the thing. So that's first, second, third, and fourth. So after the fourth payment, it says use your calculator to find the loan after the fourth payment. So if we were writing that out, it's very small, not quite finished, but we're going to round to 2 decimal places because it's money. So we'd probably say the balance of the loan is 0.04, or you could say 4 cents is still owing. And then it says find the balance of the loan after 2 payments have been made. So we can already see that. So after 2, we go back here. You can see there's the 2. So the 2 is $506.23. Okay, so the next type of scenario that we're going to look at is annuities. So and it can get a little bit confusing, but what a general annuity is that you generally, an annuity is you invest money into the bank. So you invest money into the bank and you're going to make interest, so to make some interest on it, and then while it's doing that, you are going to be using some of the money. So you're going to use some of the money as it's going, which means you're sort of making a withdrawal. So if you think about it, because you're going to use it on a regular period. So you're going to use the money or make a withdrawal on a regular basis. And so what people do that, they might have it, so you might be, say, you're going to go on a holiday, and a big holiday to, say, Europe. So you said, I'm going to use $10,000. So you pop it in the bank so that it will still make some interest while you're there and while you're using it. Even though you're taking some away from it, it's still sort of getting interest on it. But the thing is, it is still going down in value because you're using it, which is why we see that D value is a negative D. So it looks very similar to a reducing balance loan, because, you know, in the same thing is that you borrowed but you're going to pay it off. In this instant, it's your money and you're just using it out. So the only thing is to be wary of is that sometimes they do use the word, they have used the word annuity with additional payments. So that is just with additional payments added. And that is it's a bit of a different. We did look at them. That is just like you earning compound interest and adding more, and we looked at that in 8A. So that's just compound interest plus, you know, extra payments added in. So you have to sort of just be careful and read what they're actually asking. Is it a real traditional annuity where you are actually using it out, or, you know, taking payments out, or is it just sort of an investment? So just be careful with this one. So anyway, we're going to go with the scenario, the original, what it normally is, which is an investment that earns compound interest and from which regular payments are made. So sometimes you might want to write that regular payments. It's like you're making withdrawals. Like, so you're taking it out of your bank account. All right, so you can see, obviously, you have the common ratio here is 1+, because you are making interest. So you are making interest on your investment, on your money. And so that's why it's going to be a growth. So it's a growth. And then the regular payments you're taking away, so because you're using it, so that would really be like a decay. So it's coming out. All right. So let's have a look at this example. It says Reza invests in 12,000. So we've got the VO here in an annuity. So we do want to start highlighting this because we're starting to get different things. So our notes, our summary sheet will have annuities in there as well. That earns interest rate of 6% per annum. So that is my R value. And they're going to tell me it's compounding monthly. So that gave away that PPY was 12. And providing with a monthly income. So this, your income, your payments and your compounding period are always going to equal. So we never do anything different. So just if you want to write a note, your compounding periods, so meaning your PPY, so if it was monthly, is going to be the same times as payments. So what I mean by that, we had it's compounding monthly and your payments are monthly. So there you go. So they're going to take, in this scenario, she's going to take out a monthly income of 2,035. So that's our D. So the first one, it says model this annuity using the recurrence relation. So of course we need to find out that R value first. So R value is 1 plus the rate over PPY over 100. So in this case it's 1 plus the 6 over 12 over 100, which ends up equaling 1.005. Okay, so now I've done that, I can write the recurrence relation that they want. So VO was 12,000 and Vn plus 1. How we get the next term is we times it by that number greater than 1, so Vn, but we're going to minus that income, which is 2,035 every month. So then it says, using your calculator, to find the value of the annuity after the first 4 months and round your answer. So you can see I've dropped it into the calculator. Remember we set it up, so I put the initial amount, press enter, and we get it there. Then I press times, and you'll see answer come up, and then I did times the 1.05 minus that, all in one go, and I get this is after the first month, and then I just keep pressing enter, and I get the next one, the next one. So just keep pressing enter. So second, third, and fourth. So I can just read off the calculator. So V4 was $4,040.55. Okay. Okay, with this example, the value of an annuity, so this is where we need to start highlighting that word. We're doing an annuity after monthly payment, so they're getting paid out. So when I read that, monthly payments of $505.55, just that's a minus D is what's happening. They're taking out the payment. Can be determined using the recurrence relation, and you can see that there in the recurrence. And it says just find the value of the annuity after 5 payments have been made. So here I'm doing it again in the calculator. We press it 100,000, press enter. Then when I write times, it should say answer times, and then you type this in, and we get that. So this is the first, second, third, fourth, and fifth. So remember, you can just keep pressing enter, 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 and you get them. So I can see here it's 98,467. So that's closest to C. When we were talking about how we get the end term, when we have to get a value many periods away, so many periods away, so I mean say this was a monthly formula, I say in 6 years, that would be 72 months away. So when we want to get a value many periods away, we will eventually, what we will do is we'll use finance solver. Okay, so we'll learn that in a little bit, but just so you might want to write a note there.